Welcome to episode 2 of Phaser Pong. Today I'll be looking at creating an opponent and hopefully also some AI. First of all though, let's start with changing something about the acceleration, which is I actually don't want to constantly keep on adding to the acceleration. I want to cap it at a max speed. So I will go to my constants and I will create a max speed variable. I'm going to call this 250. And what this will do, or rather how I'll use this, will be down here. So I'll do something like const current velocity equals this thing. So now we have current velocity, and now we can say that our velocity equals. So when the up key is down, means we're going up, which means we want to decrease our speed because 0, 0 is at the top left. So we want to do math.min, math.max. Math.max, min. We'll just try both. So the lesser of these two expressions, and this will be current velocity minus acceleration or negative max speed. Let's see what happens. Moving very slowly when we're going down, but up it goes really quickly. So let me think about this. Okay, we want it to be math.max because we want to keep on taking away from the current velocity, and the least that it can be is negative max speed. So that should work. And now let's do the same thing here. But here I'm going to say math.min. So the smallest of these two is going to be plus, going to be max. And now we should accelerate and then reach a top speed of 250 or somewhere close to. I will keep open my console here and I will log current velocity. Now let's see, so it is current velocity. So 0, 247 minus 247. Okay, that's good. We have the speed, which is capped at the maximum speed, or roughly thereabouts. The next thing that I want to do is refactor this paddle to be a class, and I want to use I want to extend Phaser's rectangle game object. So there's this great website, Notes of Phaser 3 by Rex Rainbow. And here he gives us an example of how to define a class that extends a Phaser class. So I'm going to create a folder, entities. And in my entities, I will create a paddle.js. And I will paste in this class declaration and I will export paddle. Export default paddle, and this will be named paddle. Now, basically what I want to do is to put the initialization logic from the paddle into this class. So I'll be calling const paddle is new paddle. It auto imported it, and now I want to give it the scene, which is this, and otherwise all these things are the same. So here we go. And we can get rid of this. we can also put all of this thing into the paddle class. Here, seeing that existing this. So this dot set origin, seen that physics that add, and this dot body dot is false, and this is not paddle, but this is this. So here the this is referencing the instance of the paddle. So whenever we make a paddle, this will refer to the instance. And let's see what happens. So it looks like it's still working, and that's great. But the reason that I wanted to do this was I wanted to take all this code and put this in the paddle as well. And I wanted to do something like this paddle.update. And here I can create a function called update. Doesn't take any arguments. And here this paddle is no longer necessary. Now we can just use this. So I'll select all occurrences of this paddle, and I'll just delete paddle from them. And we actually do need something here. We need to take in the keys. So instead of this up key or in this down key, we'll just do up key and keys down key. So now we need to import this again. So I'll quickly delete and just type it again. Same for max speed, same for drag, and I think that's it. Except we are trying to read up key of undefined, which means that we need to pass in the keys. So const keys equals an object, and it has up key and down key. So just these things, but with some differences. So this is this, and here we go. And we can call now it works again. Great, that's amazing. Let me see if there's anything else that we can do. No, that's it. So now we have the paddle in its own class with its own separate logic. This will come in handy later. Now for the next part, I want to start creating a computer player. And for that, I want to figure out where the ball will end up after it collides with my paddle. So to do this, I want to basically draw a series of lines. Since we can predict where the ball will bounce, because we know that it will just kind of reverse its velocity in both directions, we can draw a series of lines and basically predict where it will collide with the other part of the screen. So I've done this once as part of prep, but I'll actually just copy paste this function here, and I will go through this line by line because it was quite difficult to get right the first time. So first of all, we have something called this.graphics. So this will need to happen in the create function. So we will do a this.graphics. Let me see. So this.graphics can be something like this. This is just adding the capability of drawing graphics on the screen onto this scene. And it'll live under the keyword this.graphics. So here in our function, which is called getBallAngle, we say that whenever our graphics So here in our function getBallAngle, we say that whenever our function draws a line, it's going to be of thickness 4 and the color will be red, and it will draw the line that is given into this function. Then we set the line to be the current line. This is a variable that we will change, and we will draw a line on the screen which corresponds with the right angle of the right side of the screen. So we should see a moment. Okay, we're never actually calling this function yet, but that'll be fine. Then we draw it on the screen. Then we get its length. Actually, we get the length of line, but it shouldn't matter because they're all the same length anyway. And then we go through this loop. We have this let variable, and we say that while this is not true, because we don't know how many times the ball will bounce, we will draw a line from the current position of the ball, which is the end of the last line, at an angle at the reflect angle, or like the 45 or like the 90-degree angle, until it collides with another wall. How do we know that it collides with the other wall? Well, we have these two lines here. We will call up line and down line, or this dot intersecting lines up and down. And these will be lines that we draw on the screen. They will just basically keep track of the ceiling and the floor. So we cannot detect this is basically the only way that we have to detect that the line that we are drawing is intersecting with the bottom of the screen or the top of the screen. So I'll show you what this looks like in action. So we need to find where we are adding the collision between the paddle and the wall. So that's here. And this actually takes a callback function as a third argument. And this function will be called whenever the paddle collides with the wall. Sorry, I don't want it here. I want it when the paddle, where is the paddle? This is the paddle and ball. I want it when the paddle and ball collide. So here I want to do something like this. I want to say a new line from the ball position of x and y in the direction of the ball velocity. So after we collide, the ball will have swapped its velocity. It will now be heading in the new direction. And I just want to draw a line that reflects, that shows me that direction. And this should do it. This is the ball. Let me see. Do I have... Okay, I don't have ball on the scene here, so I'll do this dot ball equals ball. And now let's see what happens. So now we're drawing a line here and we're drawing a line here. So it doesn't line up exactly because it's to do with the fact that the ball is 20 pixels wide as well. So it doesn't line up exactly, but it lands up almost. And so we have here on the left-hand side an intersection between the vertical line and the line that's coming from the bottom, and that's where we know the ball will hit the right side wall. So this is basically enough to tell us where the ball will be and where our computer opponent should go. Now let's try to actually implement a computer opponent. Also, I want to say that I didn't figure this out alone. I got a lot of advice from a very helpful user on the Phaser Discord called Flo. So again, Flo, thank you very much. This was really, your reply was very helpful. Alrighty, now to make an opponent. First of all, we want to make another paddle. And this will be something like opponent. Yeah, it can be opponent. And this can be opponent. And we don't want it to be, so this is the x and the y, so we want to say 800 is the width. So 800 minus the width of the paddle minus 10. So this draws the paddle here. And now we want to move the paddle. So this has all the same properties as our paddle because we're using the same paddle class. This guy, great. And now here, what do we want to do? We want to call this .opponent.update. And if you're passing keys, then it will move together with us, which is kind of fun. Okay, we also have to set it to collide the ball. That's good. So where are we setting the physics.add this the paddle ball? Okay, so this physics.add collider, this opponent ball, and actually let's say that this target is null, and say this graphics here to delete all the lines. Let's see what happens. Okay, now, and we go and we collide now, and we nice. Now we have it here. It looks good. And now we just want to do some simple math. We want to say something like we want to figure out where the I'll just start from the beginning. Let opponent keys. And this will be similar to this thing, but since we don't use the actual up key object, we have to create it ourselves. So let's look at what this is expecting. So it's gonna taking keys, then take up key from that and checks if it is down is true. So we want to do up key is down. So this would be an object, and this is down. This will be false by default. Now we can repeat this, and we can call down key, and now we can give this opponent keys. Now it shouldn't crash. Okay, it does not crash, but it doesn't do anything either. So we want to say that if this target, I believe this is where, okay, this the target, we return target. We don't actually want to return the target, or do we? Ball angle, where are we calling you? Okay, yeah, so we're saying this the target equals this get ball angle. So if we have, if this the target, let's see if this target, if this target position, let's have a position. Maybe it just says an X and Y. I think it just says an X, because it's the intersection, not the body of the ball. So it has a Y. I want to say if the Y is greater than this opponent body position Y. So if the target Y is greater than our Y position, that means that it's below us on the screen. It means that we want to press, quote unquote, down key. Is down. Else it must be above us. So we want to say not down key, but up key. And it's true. And now it should already move based on target's position. Okay, nice. Almost. I think what's the problem is that we're looking at the center position, so we need to subtract half of its height. So I'm gonna put that into a function actually. Instead opponent.get center position. I will now go here. Now it froze because it's trying to run this code, but it doesn't exist. let's say this dot get center position, and it returns this dot body dot position y, and we need the height. So we're going to say this dot height, and we want to say minus this dot height divided by 2. So now it should go to the center. See? Okay, nope. Okay, so I'm probably putting the yeah, the origin is at 0, 0. So I want to add. There we go. Now let's see. Yeah, so it's still jittering around here a little bit, but I think that's all right for a first attempt. I will call it a day here, and in the next video, I'll implement what we need to win the game, to lose the game, and maybe some other bits and pieces here as well. But this is already quite good so far. So yeah, thank you very much, and see you next time.